So now we're going to look at the influence of potassium and muscle juice on the sensory to CNS to the motor nerves. We're going to use a little different preparation, but we're still going to use a crayfish abdomen. So right here we have the suction electrode. There's a wire on the inside and a wire on the outside, and you're going to want to make sure that the saline is above the wire on the inside. And these two wires are going to pick up the differences in nerve activity, and we're going to plug this into the amplifier here on the two on the outside, and then we're going to put the ground in the middle. And you're going to want to make sure that these don't touch. And then you also have a ground in the bath, which is connected to the Faraday cage and the amplifier on the outside. So this is the extracellular amplifier. You have the input right here, which connects to the head stage. You have the ground, and you have the output over here, which connects to the A to D board. You can modify the gain as you choose, and for filters, you use the low and high pass over here. So this is lab chart 8 from ADI. So once you're at the Welcome Center, you can X out of here and get to this page. Go to Setup, Channel Settings, and then we're going to make it just one channel. So we're going to set the acquisition rate to 10K. And then we're also going to go to Input Amplifier, going to select differential and AC coupled so it will stay at the 0. And then we can start. So just like we did before, we're going to take a crayfish, put it on ice, and then decapitate it, and then cut off the legs, and then we're going to cut off the swimmerets, these little swimming things on the abdomen. And you can take a paper towel and just brush them off. Then we can put it in the dish. I'm going to pin the tail out with these. So if the prep is too big and you can't stretch the abdomen out enough, we can cut the thorax off to make it easier. So to cut the thorax off, first you want to hold it with your thumb like this so it won't tail flip on you. And then we're going to cut along here and cut as high as you can and when you get to the top, don't pull the ventral nerve. And here's abdomen. So you're going to want to pin out the abdomen so it's stretched out. It should be a little bit curved. So you're going to want to carefully cut into the second segment of the abdomen, and you're going to want to cut into the articulating membrane. Not too deep, because the ventral nerve cord runs right underneath this blue line. So now you can take your scissors and go into that cut and cut the rib. And make a little notch in the rib. That way you can see the ventral nerve cord underneath. Now we need to open up the articulating membrane. So there are 3 roots under the first rib. The first and the second root go to the ganglion. The third root comes off the connective and is connected to the muscles under the articulating membrane. And these are the superficial flexor muscles. So we're going to cut the articulating membrane so we can expose the third root. So we cut down this way, and then we're going to cut close to the articulating membrane so we can open up the flap. And now we can peel the flap back and cut it off. And now we have to look for the third root. And we can do that by pushing the connective to the other side. So first we're going to pull up some saline in the suction electrode. And now we're going to move this electrode over the nerve. And then you can use the microscope to find the nerve and pull it up as well. So once you pull up the nerve in the suction electrode, it might be a little bit loose, which would cause a problem because it might fall out, and it's difficult to get extracellular readings off of that. So what we're going to do is we're going to take these tweezers and we're going to pack it gently with Vaseline, and be careful not to pinch the nerve. So we're going to carefully pack it with Vaseline to make sure that, first of all, it doesn't fall off and the resistance is high enough to get good recordings. So after we got the nerve in the suction electrode and you put the Vaseline around it, you're going to want to make sure that both the grounds are in here, and you're going to want to ground yourself too so you don't have any 60 cycle. Another thing, you might want to turn off your light. That can also cause some noise, and make sure to pull the wire inside the cage or take the light out altogether. So you can see if I'm not grounded and I put my hand near the electrode, there's a lot of cycle noise. But then when I ground myself, a lot of that noise goes away. So now we're going to want to stimulate the sensory nerves, which is going to stimulate the CNS and then the motor nerves. We're going to do this by brushing or pinching the cuticle. Now I'm going to brush. One more time. Now I'm going to pinch the cuticle. Be careful not to move the prep. Pinching. One more time. So, like we did in the experiment before, we're going to wash out the saline, which was our control, with various potassium solutions and muscle juice. So as long as you don't use too high of a potassium solution, like 80 or 100 millimolar, you can see how long it'll take to wash it back down to the control, which could also be an interesting experiment. So other inquiry-based labs that you can do, along with the topic of deep tissue injury, is along with potassium, amino acids also spill out when cells are damaged. So you could look at high amino acid concentrations on healthy cells. So another inquiry-based lab that you can do is looking at the effect of Another inquiry-based lab that you can do is looking at the effect of insecticides on crustaceans. So, as in this lab, you can see that the sensory nerves release acetylcholine to the CNS, and insecticides target that. So we could see if the same thing would happen in crustaceans. Would insecticides work the same way in crustaceans? And we could also try that out as well. So to mark when you're brushing, you can add a comment. So you would go and you can just select add, and it's gonna mark wherever, see, it's gonna mark wherever you start brushing, and then you hit it again to mark when you're done brushing. So in the first experiment, we recorded resting membrane potential. In this one, we want to record the resting membrane potential and the synaptic transmission. And to do that, we're going to have to stimulate the motor neuron. So how we're going to do that is we're going to use this suction electrode, and we're going to first fill it up with saline. You're going to fill it up above the wire, and then you're going to move it over to the motor neuron and suck it up. And so the motor neuron might be a little loose in the suction electrode, so we're going to want to pack it with Vaseline so it won't fall out. And then we're going to take intracellular recordings. So to stimulate the nerve, we're going to use this stimulator over here, and we are going to have the frequency at 1 hertz, and we're going to gradually increase the voltage. And for these two settings, you can look at your lab protocol. If you were thinking about an inquiry-based lab, we could also look at the amino acids that might affect the muscle as well. So knowing that the neurotransmitters is a glutamate receptor in the crayfish, it's acetylcholine in mammals, think about which amino acids and how they would affect these glutamate receptors. So now think about these amino acids on mammals. Think about how these amino acids would affect acetylcholine receptors. So we might not have a cheap mammal prep, but we could also use a frog prep like a lot of labs use. Now think about the next experiment we're going to do. So in the next experiment, we're going to look at the sensory to CNS transmission. And here we use acetylcholine receptors as well. So we could look at the effect on amino acids and potassium and extracellular components such as those.